Severe weather in November is usually pretty rare, but it looks like we're going to have one last hurrah. At least, this is at least one last hurrah of severe weather for the year. So for Sunday and Monday, we seem to have severe weather set up working here in Texas and Oklahoma, down in the south where you would expect it. What the SPC is talking about right now seems to be a QLCS tornado, or not tornadoes, excuse me, QLCS situation that could include tornadoes, but as of now, they don't know too much about the specifics. But I'll be looking at that today, just to set up, understanding what I can. Hopefully, I will have at least a community post, if not another video out about this, either the day before or the day of this event, or both. We'll see how it goes. So I'd like to add some new products into my videos now, and especially for this one. So we're going to be learning a little bit of new things about this setup and just forecasting as a whole, just because I've been at college enough now, and I'm starting to, understand a little bit more as I've been going towards my degree. So what I'm going to start out at now is by simply looking at, what's our setup right now. So the models for future setups like this are probably the most important, but what you can see here, this is actually an analysis map. See here, 500 millibars here. We definitely have this very potent trough off Rockies over California-ish, and a big old ridge over here, kind of kind of near the south, right near Louisiana. But then, again, just that normal flow, a little normal little wavelength, like up and down, that kind of thing. And that's where we're at right now. If we look at the models, what they will do is they will move this over. So let's actually look at the ensemble GFS right now, just so we can see the general progression. Again, moving a trough off to the east. However, it looks like this trough gets split up a little bit here. In northern, kind of get that cut off. You can see where the jet stream starts to go back right here. Then you have this other, area of low pressure down here that starts to strengthen. You can definitely see it right here. Much more negatively tilted as you go on later into Monday, into even Tuesday morning right there. And if you look at the GFS, you'll see it's a little bit more well defined. Again, cut off low, very negatively tilted into Tuesday as well before it gets eaten up by the main flow again. So let's look back at the NAM now, because the NAM is what will be helping this forecast the most. The RAP just simply cannot get out as far as I'd like it to. And regarding severe potential, at least in the United States, that is not very likely tomorrow. It's more likely on Sunday and Monday. And you can see here, just can't get out far enough just quite yet with the RAP model to look at that. So right now I'm going to look at the surface just so we can see how the moisture is advecting into the region and how it will be. Starting here, our initialization. Again, this is just real data based on what we have. Moisture is kind of a mess. It's not really any, just not really any moisture at all. But as this low pressure here, 500 millibars, and really just aloft, starts to move its way over the Rockies, you're going to get that Lee cyclogenesis. You can see here, there's already a surface cyclone forming off to the north, but that should help to start sending that moist air advection from the Gulf and send it up northward. But what's more important here is that we get solid, good moisture here in Oklahoma and Texas for the severe weather setup. At least if you're wishing for it to go off. That's what the setup needs, is for that moisture to advect. And you can see here, following the wrap run, we do start to get that cyclogenesis. Not very well defined, unfortunately. You can kind of see that lowering pressure. I'm going to go into the NAM here just so we can go forward a little bit more. Monday night seems to be when that really starts to go on. You can see how strong this low pressure is. 30 knots of flow at some of these barbs. So it's 28 knots right there. That's kind of very impressive. Oklahoma here as well. Very strong winds. That will really help to advect a lot of that moisture. And you can see how quick this happens. You have lifted index thing going on there, but that surface cyclogenesis occurs over Monday night. You can just watch all that moisture just move its way up here into Oklahoma very fast. And there's a 66 isodrosotherm all the way up here in Oklahoma very soon after. Widespread 60s moving into Kansas. So lots of very good moist air advection. Then almost here, again, another region of Cape it looks like that goes on later, but we'll get into that in a second. Again, what's really important here is vorticity advection too, and this is something I don't really look at very often on this channel, so I'm going to try to do that a little bit more often now. See our wrap here. Once this cutoff low here happens, kind of in Baja California, off the west of Mexico, you can see a very strong vorticity. So that's a lot of vorticity right there. You see the bright colors there. I'll go to the NAM as well. You can see this gets very widespread. That means you're going to get very quick surface cyclogenesis, because Again, vorticity aloft will really help that cyclone to strengthen. And same thing here, lots of vorticity advection to really help to strengthen that cyclone. We're going to set on down to 700 millibars. Excuse me. We're going to look at wind speed again. Lots of strong winds, so lots of forcing to be had with this system. Relative humidity as well. Very humid air here, very moist. Really help to fuel any storms and keep them going. Not looking at dry air entrainment, at least not until later here. See kind of that dry line cold front afterwards, heading behind it. 850, let's get temperature advection. I'm going to move closer so we can see it a little better. I don't trust the blues here. Let me just say that. There's not going to be multiple waves of warm and cold air advection. This is all warm air advection. Look at theta E. Look how much warmth this is. Look at the dew points. It's so moist. Lots of moist air advection, warm air advection, temperature advection, and just lots of warm air advection. You can take a sounding from wherever you want here. It'll be a lot of moisture here. Relative humidity almost at 100 in some of these spots here. So lots of moisture there. You can see here, look at that, all that warm air advection. Just a random sounding from the NAM. Probably not in any important location really here. They're just, again, everywhere along here. You can see this is the temperature advection here. Warm air all the way up to over 500 millibars. So a lots of warm air advection, which could help to actually dampen some of the severe threat, but especially in those lower levels, you can see much stronger warm air. Now we'll get into the issues with the system after that. But yeah, here's the surface. Again, we talked about the dew point, very moist air. You can see mixed dew points here. Again, same thing, lots of good moisture to really help this system out. Very strong winds, and it just looks like a setup that's going to be very dangerous. However, there are some flies in the ointment, which are important to mention. So, since we are so far out, it's going to struggle to. The models are going to struggle with instability. One thing in particular here, again, this would never be enough instability for a good severe weather setup. See, STP is definitely blowing up, but I don't want to really look at that. Look at SRH, you can see the values are through the roof here. Look at this. Some of these areas, 800 meters per second squared. Wow. 0 to 1, same thing. Just so much SRH right here. You take a sounding right here. And interesting location. But yeah, we can see, I'm going to draw this is at 12Z here. Kind of a morning setup, surprisingly. Here's our low, very well defined. I would place the warm front. You check the moisture a little bit here. Probably right here. Here's our warm front. You can see the little bit of a wind shift, so stronger, more southeasterly. And here it's a little much more easterly component, a lot weaker winds. Our cold front very well defined on this map. Actually, surprisingly not, but I would probably place it somewhere here. It's a little hard to tell. Let's actually look at Duke. Somewhere along there, and it'll probably strengthen very quickly. By the next frame, you can see that cold front much more well defined. Yeah, you can see that moisture gradient a lot better there. So definitely this open warm sector, especially Oklahoma being our main area of interest, if you ask me. Here's our SLP sphere. Ignore this for 1 minute, please. But SLP, MLP severe. This is the Colorado State University Machine Learning Program. I don't like to look at it too often, but it is kind of a fun model, kind of model output to look at. Just looks at different, things that have happened in the past. Says, hey, how likely is this to occur again? Has that tornado maximum right there in central Texas, right here, close to that cold front. Probably that strongest leading edge of the cold front in any like QLCS situation that occurs will be right there. Actually, I will delete this now. Let's look at the day 4, what it says, or excuse me, day 3 for now. I know it mentions the QLCS. Yeah, QLCS circulations are possible. They seem to have confidence in a windstorm here. Now let's check day 4, see what they have to say. Nightly tilted trough, as we said earlier. Yeah, so it says severe wind gusts are the main threat. Again, here's thunderstorm potential right there along that corridor. So that's probably our main region, is right in here. I'm going to take a few soundings now, just because it is what I like the best. But again, it is important to note that the soundings probably won't be amazing because we're so far out from the system actually occurring. I'm gonna take a sounding from Kansas and one earlier in Oklahoma too. I like my soundings, and it's personally a way that I prefer to look at the environment. It's a very nice method that way, in my opinion. So here is a sounding. Oops. sounding from there in Texas, but it's saying it's all gray right now. But you can see ridiculous photographs, like absolutely insane. Actually, look at the yeah, the bulk shear is ridiculous. So these storms are moving very fast, so very dangerous to chase probably. But you can see the bulk shear. Wow, 65 knots, kind of impressive, really impressive. You can see the 850 millibar winds. I did forget to look at that actually. They're exploding. The lower level jet is extremely strong at this point. You see the upper air cold front right there. Yeah, definitely upper air cold front right there. Very strong lower level jet though, so that could really help to rotate a few if that did occur. I'm gonna close out of this sounding here. You can see with actually this is an interesting sounding too, is right there in Kansas. So if you compared that other sounding, let me take it right here in Texas. You compare this Kansas sounding with this Texas sounding, you'll see a very obvious difference being that the lapse rates are completely different. Here's our lapse rates for that Kansas sounding, much steeper than our Texas sounding, and like really no cape here. That is something worrying. So we have so much warm air advection that it actually leads to, you can see here the temperature of 500 millibars. There's 500 millibar warm air advection, which isn't usually what you want to see. You want to see colder air aloft, so that way your partials will be more buoyant, they'll be warmer than the atmosphere, and they will rise. But right now we're seeing a lot of warm air, -7s. I believe there's also a lot of drier air here, so there's a potential fly in the ointment for sure. See a lot of dry air moving its way in very quickly there, so that could be a potential issue for this setup. Same thing here at 700 millibars. Again, lots of dry air moving in quickly. Might even see it here. Yeah, again, dry air everywhere there. So very fast moving cold front aloft, which could really damper severe threat quickly. But if the conditions are right, for example, here, we get 500 millibars. Let's relative humidity again. This sounding right here is taken at 0Z, sorry. 0Z here in Kansas, kind of in that vicinity. It's a lot colder there. Also, I believe there is more moisture at the other levels. Yeah, more moisture behind. Here's their big surge of dry air, but back here a little more moisture. You can see this sounding looks a lot better. Big moist layer, even weaker winds, which could help. And you can see all the cape is confined to the lower levels. Weaker winds do not help the tornado threat, but again, weaker winds. But the real thing here is the lapse rates, and that's what I'm kind of most interested in. Your partials will be very buoyant immediately. 303 cape almost there. Very impressive. 150 SRH, that's plenty, honestly. Likely surface vorticity as well. And right there. So I'm very interested in this region for your potential tornado wise. Again, the same thing. Behind that region, much more shallow moist layer here, but a lot of 3 cape. Okay amount of SRH, could use a little bit more, but the same thing. It's probably right by that vorticity right there. There's your vorticity again. Here's another sounding there from ahead of that cold front. Massive wind shear, but the lapse rates are not helping here. Looking at the bottom, surface to the 3 kilometers, only 5 degrees Celsius per kilometer. Not very good at all. They could use better. Same thing here, as I said earlier. So that is really the potential issue with this setup is ahead of the cold front here, there is so much warm air advection at every level that it actually helps to dampen your severe threat, especially the fact that drier air will be entraining very quickly into this region. Has me a little bit worried for how the setup will look as a whole. There certainly is severe potential with the storms that are on this line and on. Because if you look at, again, take a sounding ahead of this, you can see the ridiculous curvature of the photograph. I mean, that's a lot. If you ongoing storms, that doesn't matter. Here is the same thing here. Ahead of that ongoing line, the NAM had lots of shear. That's very worrying, especially warm air advection. And this one is mostly confined to 850 level, so that is something to keep in mind there. So as a whole, again, definitely a severe threat on tap here. Interested to see how it will play out. Again, this 500 millibar trough looks very scary. There is something to be said for this upper level cold front. So as we get closer to the date, I am going to make another video just so we can see how things are changing, if there still is that dry air entrainment, or if we are just going to have a severe weather setup as normal. So we're just going to have to wait a little bit. So for the meantime, I thank you very much for watching. and I'll see you next time.